To extract a subcatchment that has a sense in a topographic meaning and this hydrological ecosystem, we need to use the terrain model. So in this case, we use the terrain model that is available in Google Earth Engine. It has not a very high resolution, but for our purpose in this case is sufficient. We load it, and then I'll display it for the entire Norway. Terrain models in general are large files, so it takes some time to load. It's also not possible to work with the terrain model for the entire country. It's too big. So we need to subset it again. In this case, I use the region boundary and I load the terrain model for Vest-Agder, as I can show you here. Yeah, we load the terrain model for this region. So Google Earth Engine and GRASS, they work in different way. Google Earth Engine is a web-based tool and GRASS uses local data. So what we need to do is to export the DTM from Google Earth Engine to a cloud folder and then upload it in TwinLab. Exporting from Google Earth Engine is probably the most time-demanding operation. So I already did it. It might take even 15-20 minutes to export. It's exported from Google Earth Engine to a cloud service, and then from there is imported in TwinLab. Now we start to use GRASS. So first thing to do in GRASS, I already did it, but is to set up a location. It's called location. It's where we import the maps and we perform all the analysis. It is a very useful feature. When we define a location, we have to define which projection is that location in. And every time we import a map, the GRASS will check for consistency of the projection. And if the maps are not the same projection of the location, it will give us an error. That's very useful to avoid calculation problems and using the wrong projection. And it's also useful because sometimes we don't know the projection of the map. So here I start a GRASS session, then I import the DTM, I set the calculation region, and I show you the DTM. This map is not interactive, it's just a graph, it's a matrix with some colors. Here, from this, I need to extract the stream network. Why the stream network? Because when we choose the point upstream of which we need the catchment upstream, the point has to be in some areas where the script can calculate the drainage direction. If we calculate the streams before, we know where these points are. Here I use a high threshold, so it means that only the large rivers and streams are calculated, and is fast. If I reduce the threshold, we have a much more complex network. Then I export the data into another format and import it into Google Earth Engine. Again, here I show you, yes, this is the network of the streams that we calculated. What we need to do now is to use again the inspector tool as shown into the previous example. We can zoom in and pick a point along the stream and say, give me the coordinates, which is this data here, this data here. We copy and paste it, and we run the script to analyze the subcatchment. Is already run, so now I add it to the map, to a map. Here is the catchment, as you can see, the whole catchment. Now we need to extract the shape from here, upload it into Google Earth Engine, and cut the land cover data on this catchment. Here's these instructions here, is run, and now the result is the land cover data for that subcatchment. As you can see here, is upstream of this lake. That's one of the many data we can extract from Google Earth Engine using this kind of workflow. In hydrology, for example, might be very useful to extract precipitation data, temperature data, wind data, evapotranspiration coefficient if we have it. Unfortunately, many precipitation data, they are available, but just for the tropics, so we can't use it obviously in Norway. But this is just an example of how we can use the workflow in TwinLab to do some geographical and spatial analysis. In the next video, we will show you how we use this data for hydrological modeling.